Hi, this is Calandra. In this video, we're going to go over the meaning of polynomials. So first we're going to start off with some definitions. A term is an expression that is the product of numbers and variables. So some examples of terms would be 5x squared. When there is no operation written between the number and the variable, it's understood to be multiplication. So we see that we have a product of numbers and variables. Negative 2xy, 1/2 ab. All of these are examples of terms. A coefficient is the number in front of the variable. So if we go back to our terms again, in our first term, the coefficient would be 5. In the second term, the coefficient is negative 2. The third one, 1/2. 3 would be our coefficient in the fourth term. If you look at the fifth term, there is no number written in front of the x. So you need to remember that when no coefficient is written, it is understood to be 1. So since that happens often, instead of writing 1x or 1 times your variable, we just write the variable, because 1 times anything is just itself. A polynomial is the sum or difference of terms, where the exponents of the variables are whole numbers and the coefficients are real numbers. So when we just add and subtract a bunch of terms together, that gives us a polynomial. Key to remember is that the variables do not appear in the denominator in polynomials. So keeping that definition in mind, in our next example, we want to circle the letter of the expressions that represent polynomials. So starting with A, okay, I see I have the sum and difference of some terms. All of my coefficients are real numbers. And when I look at the exponents of my variables, those are whole numbers. So this meets the definition of a polynomial. For part B, okay, we have one term. Our coefficient, negative 3/2, is a real number. Any number you can think of is a real number, except for something that you're going to learn later called imaginary numbers, where you're going to have the letter I involved. So as long as you don't see an I, what you have is a real number. So we're good to go with the coefficient. When I look at my variable, my exponent is a whole number. The variable is not in the denominator. So B is also a polynomial. Okay, looking at C, this one looks a little strange because we just have a number. But if you wanted to write it in terms of a variable to make it easier to see in terms of our definition of polynomial, we can do that. 10 can be rewritten as 10 times some variable that we can call x to the 0 power, because anything to the 0 power is actually equal to 1. And 10 times 1 is just 10, which is what we started off with. So when we compare this to our definition, the exponents of our variables are whole numbers. 0 is a whole number, so that works. And the coefficient 10 is a real number. So when you just have a constant, which is just a number, that is a polynomial. Okay, if I look at part D, okay, we're dealing with the square root of x. Okay, this is something that is not in the form of a polynomial. What you're going to learn in a later video is that when you take the square root of something, you can rewrite that as whatever's under the square root raised to the 1/2 power. So 1/2 is not a whole number, therefore this is not a polynomial. When I look at E, notice I have variables in the denominator. Therefore, this too is not a polynomial. Okay, a couple of other terms that you should be familiar with. One is degree. The degree is the highest exponent of the variable of a polynomial. And if there are two variables in a term, add the exponents together to get the degree. And the leading coefficient is the coefficient of the term with highest degree. Okay, so specify the degree and leading coefficient of the following polynomials. So let's start with the degree. So the degree is the highest exponent of the variable. Usually our terms are written with their exponents in descending orders, in a descending order. However, that's not always the case. So we see that the highest exponent is 5. So that's going to be the degree of this polynomial. Well, the leading coefficient is the coefficient of the term of highest degree, and that is the number 2. Okay, let's go on to part B. Okay, so for this one, we have 2 variables. So in order to get our degree, we add the exponents together. So in the first term, we have something that's degree 5. In the second term, remember x is really x to the first power. This has degree 3. Since we're looking for the highest, the degree of this polynomial is 5, which means that the leading coefficient is going to be 3. Okay, and lastly, for C, okay, we have one variable, so that makes it easy to find our degree. We just want whatever that exponent is. When there's no exponent written, it's understood to be 1. So the degree of this polynomial is 1. And similarly, the leading coefficient, since there is no coefficient written, is understood to be 1. Okay, some common types of polynomials that you'll encounter. One is a monomial. That's when you just have one term. So if we go back up to a previous example, like when we just had 10, 10 is a monomial. If we had just x, that's a monomial. 3x squared. All of these are monomials because there's only one term. A binomial, bi, means we have 2 terms. So examples of a binomial could be x plus 1, x cubed minus x. Anything where you have the sum or difference of 2 terms. And a trinomial, just like the name implies, tri, is when you have 3 terms. So you might have something like x squared plus 2x minus 5. That would be a trinomial.